potentiometer is a common three-terminal electronic device. It's essentially just a resistive element, and we're going to talk about how that single resistive element becomes a three-terminal device and the theory of operation behind that three-terminal device. But first we have to review the concept of resistance. Remember that we learned that if we have a piece of material that's, say, a rod, like a wire, that has a cross-sectional area of A and a length of L, we can calculate the total resistance of that rod. And that is given by R is equal to rho L over A, where rho is the resistivity of the material, so that's a material property. L is the physical dimension of length, and A is the cross-sectional area of that wire or that conductor. Now, that's if we measure between the two endpoints along this entire length of this wire. Now, if we wanted to, we could imagine putting another conductor or another wire in here and measuring from this point to this point. But since the length is not the total length, it's only, let's say, little l from here to here, the resistance between these 2 points is going to be smaller than the total resistance of the entire length of wire. Okay, so in this case, this resistance is going to be R equals rho L, little l, over A. Okay, and of course the remaining resistance between here and this end is going to be the length. The big L minus this small length is going to be the total length here. Alright, so this resistance would be R equals rho L minus L over A. Okay, so you can see that by adding this piece of wire here that we're going to measure the resistance of this total wire with respect to this endpoint, or this point that we're calling 0 right here. If we move this along, if we move that wire or that measurement point along the axis of this wire, we'll have different measurements depending upon where, from which point we measure. Okay, and that's the whole principle behind the potentiometer. The potentiometer is a three-terminal electronic device, and we represent it as a resistive element. Right, in between two of the terminals, the resistance is fixed and remains the same value the entire time because R is dependent, the total resistance along this entire length is dependent upon the resistivity, the length, and the cross-sectional area of the material. Alright, so that's two terminals. So between two terminals, if you measure the potential, or excuse me, if you measure the resistance between two terminals, it's always going to remain fixed. A third terminal is then added, and that's a movable terminal. That's a terminal called the wiper terminal. Alright, and this wiper terminal can be mechanically moved along the length of this resistive element so that this length is going to change. So if you measure the resistance between this end of the resistor and the wiper, depending upon where this wiper is physically located along the resistive element, you will get a different resistance reading. Now, instead of having this long strip of wire, most potentiometers are comprised of this wire that is coiled up. Alright, and imagine, if you will, me taking this wire that has some total resistance to it and coiling it around, and then through the middle of that, so here are the fixed ends of the resistive element, and through the middle of that coil, what I'm going to do is I'm going to run something that looks like a screw lead and a piece of material that will contact this resistive element. Alright, so up through the center there's this metal contact, and then what we can do is we can put essentially a screw on top of this, alright, and we can turn this wiper element. Right? And by turning this, what it's going to do is if we turn it in one direction, it's going to continually move up the spiral and change the physical length, the conduction path length, from one end of the terminal up to the wiper terminal. So right here, if the wiper is currently in this position, the total resistance from here to the wiper will be determined by the distance along this curved path, or the coiled path. All right, as we turn it, if we turn it clockwise, in this case, it's going to move up the spiral and increase the length from this terminal and decrease the length from this terminal, giving us different resistance between the wiper and the two end terminals. But again, notice that the total length of the resistive element, the coiled resistive element, never changes. So that resistance is always going to remain fixed. We specify a potentiometer by the range of values. So if you specify, say, a 1 kilo ohm potentiometer, that means that the fixed length ends of the resistive element can vary between, is going to be 1 kilo ohms total resistance. And by varying the wiper position from one end to the other, if we get the wiper all the way on this side of the element, the resistance between this side and the wiper element is going to be close to 0. And if we bring it all the way to the other end, if we bring the wiper all the way to the other end of the resistive element, the resistance between one end of the fixed element and the wiper is going to be the full resistance of the element. So a 1 kilo ohm potentiometer will give us a variation between the wiper terminal and one of the fixed ends of the resistors of 0 to 1000 ohms of resistance. Now, in addition to acting like a variable resistor, so you can cause the potentiometer to behave like a variable resistor by, say, putting a power supply and connecting it to one of the fixed ends and one of the wiper terminals, and we could vary the current that passes through that depending upon the position of the wiper. Another way that you can envision using this is to set up a variable voltage divider circuit. Okay, so by placing the by changing the position of the wiper, we can change the output voltage across the wiper terminal by changing its position along that fixed element. So by using the voltage divider equation or the voltage divider relationship, we can by turning the knob of the potentiometer, we can change the output voltage and be able to tune that even though this input is a fixed value. Okay. So that's a brief overview of how potentiometers work and the principle behind their operation, and you will get to see those in labs.